Welcome to our business track of the Data Science Salon YouTube channel. In this talk, we have Sayan Maity, Senior Research Data Scientist at Roku. Sayan will share how cutting-edge machine learning techniques can be leveraged to solve the core business needs of expanding the customer base without impacting the brand perception and by minimizing fraud in the context of product-based consumer model. I hope you enjoy the presentation.
Hello everyone. First of all, thank you to Data Science Salon to give me the opportunity to talk about how we can apply machine learning and AI to solve holistic business problem. And also I want to thank all the audience members. Though this format of the talk is a bit different than the usual conference session, but I would really encourage if you can keep a note on the questions, and at the end of the talk, we can have the conversation. So it seems like it's still interactive, though it's very different than for the ongoing pandemic going on. So going through the agenda, I just want to initially introduce myself so the audience will know me a little bit better, and also trying to make sure that I'm qualified to drive this topic. And then we're going to be delve into the objective to summarize the message of the talk. And then we're going to be talk about what is the usual life cycle of a business growth and how the usual data science project scope has an inherent relevance with that. Then we're going to be going into the meat of the presentation, that choosing explicitly examples of instances of the cutting edge machine learning models can be applied in the different facet of the growth of the business process cycle and how we can leverage them. And next step is going to be trying to give a quick overview that how each and every stages are interconnected, and changes in any one of them have a huge impact on the performance on the other components, if not optimized for those specific changes. So throughout my talk, you will listen to a lot of messages, and those topics can sound familiar or redundant in any case. However, I would encourage to bear with me and take the time for refreshing your memory, as without setting up the platform and the context, the message I want to share in this talk won't be resonating enough. So just to give a quick introduction, I completed my PhD from University of Miami and spent nearly 8 years to performing research in academia to build different cutting-edge artificial intelligence algorithm to solve problem in image processing and computer vision, specifically the problem use case of biometrics identification and medical image processing. And after I graduated, I joined as a data scientist in Visa, and most of the problem I solved is around fintech, explicitly financial volatility, credit risk model, and different fraud and anomaly detection technique. Followed by Visa, I worked at Walmart's, where the business wing I supported was close to customer relationship management. So we try to understand a user's interaction with email, push notification through their handheld devices, and what is the propensity of them to make a purchase. And when they left some items in the cart, what is the propensity that they will come back and make the purchase? And how to handle those counterfactual signal that we see in our different machine learning models to build some incremental framework which would be measured the incremental effect of each and every message you send to the user. And currently I'm working at Roku as a senior research data scientist supporting the ad tech platform. So before going in, I just want to demystify what everyone's perception about Roku. Yes, Roku is a player platform. As per the last quarter, there is total 55.1 million active user, and total 17.4 billion hours have been streamed. No doubt that these player revenue brings in a good amount of company revenue. However, the major revenue comes through platform. So when I'm in platform, it's leveraging the streaming hours. So there is a lot of content that is not subscription based, such as Netflix. So you have the opportunity to show the relevant ads that can be used for the user to have a brand awareness or making some decision in their purchase. So specifically in the content that is being shown for connected TV and OTT, or also known as over-the-top media, we can we can show the relevant advertisement to the user during their streaming hours. So a couple of years ago, Roku bought a company called DataZoo, and that is a demand side platform. So just to give a quick context, demand side platform is where all the advertisers sign up for a programmatic bidding to show their advertisement. And on the other hand, this is supply side platform, where the supplier, such as CNN for a banner or YouTube for a video streaming platform, they will show the advertisement and they sign up to show the ad through the supply side platform. So Roku inherently a DSP and the SSP in the domain of the CTV and OTT media, and that give a very strong foothold right now how we would be able to help different advertisers so the ad to the relevant individuals so it will make an impact. So the project we work on is very close to the targeting and attribution. So as you can understand, we need to quantify who is the correct users whom we showed a certain ad. And for doing that, we have to build recommendation algorithms, and we use graph-based machine learning inferencing model. I also work on building models in the entire pipeline, or the pipeline for the DSP, which has a QPS, or also called query per second, in the billion. Means every second there is billion of inventory request comes through. So we build machine learning model to make sure that we're going to be pruning out and retaining those inventories which are valuables to bid on for the advertisers to show their ad. And I also work on different device intelligence, means given the Roku player that individuals look at, consume their streaming, how we can add intelligence to make it more performable with efficiency with less number of crashes. So let's delve into the topic itself. So what is the foundation of the data science? So as you can see on the right-hand side of the subspace, there is something called statistical mathematics. So we're driven by a passion to quantify, and mathematics is the mean through which we attain it. And on the left-hand side of this subspace, you can see it is computer science. So if we go back to the core, computer science has been innovated to solve problem in scale. And we build routines to perform the repeatable tasks with precision in the computer, and that we call algorithm. And the language we build this algorithm is nothing but discrete mathematics. So now we can see how closely maths and computer science are relevant, and nevertheless, machine learning is a core application which have been built based on both mathematics and computer science. So let's look at the foundation of data science. As we know, the research and development is a wing or a part of the organization from more than 100 years. However, what makes data science such as revolutionary changes that each and every business organization start adhering data science as an irreplaceable component, right? So the foundation is that data science help to make each and every day's decision quantifying the data and letting the decision unbiased and which should be reflected in the next cycle of the business outcome. So as we know, as when an organization grows, there would be the multiple organization, a smaller organization would be growing up, right? So one team can handle a certain aspect of data science or machine learning problems, and another team will be handling some other scope. However, the goal of this talk is to help you to understand from a high level that each and every team, any changes they make will impact the final pipeline and how interdependent they are. So anytime a change is made in one system, we have to optimize for it in each and every other aspect of the machine learning components that's comprehending the entire end-to-end framework. So let's look one aspect. And this is very popular proverb used in the tech industry: fail faster to succeed sooner. So as you can see in this block diagram, there are three actionable points. One is build, measure, and learn. So this is a very primitive process that our ancestor has used and we still use. starting from establishing a vision to build a product and to develop the market for it. So a faster organization iterates through the cycle, the more quickly it will find the right product and which market the product is the best fit. So if it measures faster and accurately, the success probability of company increase. Let's have a comparison with how a data science project life cycle can be closely relevant to this business growth cycle. So as we can see, the yellow highlighted portion of the data science life cycle is very closely relevant to the build and build section, where we are building algorithm, building the data, generating feature, training the model, and evaluate it. And then learning, when we are deploying and monitoring what is the changes. And based on that, we adapt and make the next cycle of the algorithm works. So let's look how these facets of business growth process can be divided in different subsection. And in each and every subsection, there is some inherent machine learning model that can be fit to solve the problem. So when a company first launch their product, the biggest hurdle is to generate brand awareness and make user aware of the product. And there is multiple techniques such as ad tech, search engine optimization, and search engine management. But what is at the core of this problem solving is recommendation. So as we all know about some techniques such as called content based, such as user preference based or collaborative filtering based recommendation techniques, or we call. However, these techniques are always built on one specific flavor. And given the scalability where today's tech worlds relies, we cannot build models for each and every feature separately. So that's why we fall back into something called graph machine learning inferencing. So let's don't get lost into this high dimensionality of the data, because there is billions of nodes in the graph and they are connected to each other with edges based on a specific quality or attributes. Though it's structurally complex, however, it's very easy to fit different development cycle. So let's take an example to make it much more easier. So in this graph, as you can see, the peripheral layer are the users who are connected with each other through what are the foods they like to eat. And we can easily build out a recommendation framework based on a graph architecture like this. And now let's talk a real problem that I have solved. So with time, a company might need to add more feature for able to perform better recommendation to identify who is the correct user for the product. So in this example, as you can see on the left-hand side, we have a graph, and this graph nodes are corresponding to devices, means a handheld device, a phone, a computer, a desktop, so on and so forth. And we are trying to build a model through their browsing behaviors so that we can show the relevant ads. After some time, we realize that we can also add another feature, such as streaming behavior. Means, if someone is interested to watching cooking show, if someone is interested to watching only streaming sports, how we can adjust this recommendation model. So rather than going ahead and build the entire model from the scratch, we will just add one more layer of features in the graph, and the machine learning recommendation model would be learn how to understand which are the user would be best fit for a certain ad. So saying that, we have seen how acquisition can help us to growth in scale by using this kind of graph machine learning based recommendation model. And next come activation. Means when there is enough user known about our brand, our product, they're gonna come and visit our websites, right? So then the question comes, how we can make the user click? So this is a quite orthodox and well popular method in the industry, where we build a framework around our life cycle of the user. Means when a user receives ads, following the ad, they come to the landing page and they sign up, and finally they receive a welcome email and they follow up. And through this A/B test framework, we try to identify how much users are getting engaged with the certain facets, or do we need to change some images, some pictures, or some other front of the website to make the user connected much better. So now let's think about a real use case. In a continuous growth of business cycle, it is inevitable that the business will go and grow in a new country. That means the same activation pipeline need to be adjusted for a new demography. So when I mean a new demography, they are coming from a very different cultural and social acceptability norm. So what we used to show in the previous country or in a different country might not work for individuals in this country. So what does that mean? No matter any changes happening in the acquisition or the growth of the business, it will directly impact the activation. So we have to optimize the changes in the activation pipeline, anything happening on the AVAP pipeline. In the same way, the next facet of the business growth pipeline is the retention. So when we have enough active user, how do we make sure they are coming back to the platform, and how we can keeping them updated with what are the product we are making available through our website, right? So let's take an example. Like there is a very niche application of machine learning algorithm called propensity model. So now when we want to target customers, right, we not necessarily blindly keep sending them communications such as the email, such as the push notification. We want to make sure we're going to be only target the population who has a higher probability or propensity to interact with this communication. So this resulted into a very interesting factor called confounding factor. It's kind of bit counterfactual. So we can easily think if we keep targeting the customer with high probability, we will keep sending the communication to the same user base, and it will becoming a never-ending cycle. So that's the reason we have to set up something called incrementality measurement framework, which will allow us to measure the impact happening for each and every communication being sent to the user. And on the other hand, we have to understand if we keep sending communication to the user who is not interested about the product, it will have a negative brand perception, and it will directly impact to the churn of the platform, right? And at the end of the day, our goal is to generate churn detection model to increase the retention. So that means if we not able to connect to the right customer in the right time and with the right message, there would be impact in churn. And so when you're building a churn model, we need to make sure that those are able to analyze the causal impact. And we have to make sure we are using some machine learning model which are interpretable. Rather than trying to drive for accuracy, we have to drive for the interpretability and the explainability of the model. So that is a very straightforward nuance that when a lot of people are going through the activation pipeline, how we have to set up for the success in the retention pipeline. And then come revenue. So at the end of the day, we have to make sure what is the bottom line of the revenue, because no business can survive with enough amount of profitability, right? And then the next hurdle comes, and that is how we can make the platform or business steady so that the revenue pipeline is not getting impacted. And to solve this problem, there is a paradigm of machine learning framework we call fraud or anomaly detection. At the end of the day, each and every organization have something called site reliability engineering team. So the individuals over there need to monitor multiple dashboards, and this magnitude of dashboard grows with time. If organization starts with 10 dashboard with 5 different feature and 5 different country growth, it will maximize to nearly 250 dashboard. And it's very easily realizable. It's very hard to manually track what's going wrong and based on that able to solve for it. So that's the reason we try to build some automatic machine learning or statistical learning framework that will allow us to identify what kind of error is happening and what we can call that's an anomaly or it's a fraud. Because as we have discussed in other facets of the business growth cycle, when a business grows and we are trying to gather and attract more user, it also gather more fraudster who try to able to manipulate the system. So you have to have something in the pipeline that will be able to identify what kind of behavior is anomalous behavior. So in that block diagram below, we are trying to display, it's a statistical model which will learn for each and every KPIs what is the usual norm, such as what is the number of time a user click on, like let's put the order, right? So it usually not more than once or twice. But if we are seeing that a user is generating a bot to buy again and again, there is something fraud going on, right? And that can be easily captured by this kind of model. However, on the other hand, these kind of static models based on statistical measurement can be very easily generate a lot of false positive. So what I mean false positive? There is a lot of the time, there is a change in seasonality or other aspect that can change the matrix itself. For adjusting on that, we can use something, a model like a recurrent neural network that will track the changes of the KPIs in the system over time. And based on that, it's going to predict what is the next best prediction for the next point of time. And if there is a huge change, the model would be able to generate an anomalous trigger. So using this kind of methodology, we're going to be able to have a normalization effect between false positive and false negative, and able to make sure that the and we're going to be able to minimize the time to recover when there was an anomalous event hit the system. So that kind of bring us to the next stage, that is the referral, right? So once we have a pipeline where we have enough amount of user, they activate themselves, and we are able to retain them in the platform, and they are generating a steady revenue, then we need the user referral, right? So it is kind of a promotion by the user that will complete this entire cycle through which a business growth happen. And as we all know, at the end of the day, a user will only promote you if they're loyal to your product or your organization or brand. And what makes a user stay loyal to a brand? And for that, there is a huge amount of models we call causal inference-based customer lifetime value that will allow us to identify what is the nuance of the business or the feature or the quality of the business that keep the user loyal. And they will go ahead and spread the word of mouth to their friends, to their relatives, to their colleagues, and that will allow us to have the viral cycle of the growth of a business. So one quite popular technique to get users' perception about a business is in market research. So an individual goes out, talk with customer and get their feedback, come back, create an exhaustive report, and give that report to the higher management to make sure to change the decision how the business work so they can keep more loyal customer. However, there is a huge suite of machine learning algorithm such as natural language processing, which can directly interact with the user on the fly just after their shopping. It can be online shopping, they can do a voice bot, and they can gather all the feedback from the users. And based on the sentiment, they can analyze, they can create an automatic feedback loop that will help the business adjust to make sure what a user like and don't like. So that's the way they would be able to maximize the user loyalty retention and going through this viral cycle of the growth by user referral. So now there is a very interesting example I want to point out that is a part of Roku. So when an individual bought a Roku TV or Roku player 5 to 7 years ago, it's quite possible that the streaming quality has worsened over time. It can be for the internet router that not support an older version of the Wi-Fi chip, or might be the content is 4K, which that player or the TV was not supported for. So we build machine learning models to very closely follow a user's experience throughout their streaming behavior. And if we understand if a user is not getting the best possible streaming experience, we try to give them an incentive, such as a discount in the next Roku device or Roku TV they will buy. And we call it Roku upgrade model. And this is the way we try to make sure the user in our platform is happy with the service they're obtaining, and they're going to be able to retain. So now, once we have taken the journey throughout the business growth cycle and try to fit each and every possible machine learning frameworks that would be best suitable, it is much clearer for us why each and every stages any change have been made will impact vastly. So we have to make sure that we're going to be able to maintain a harmony between each and every stage of this business growth cycle as business is growing and able to gather more users throughout the cycle. So now in the industry, we are very closely trying to make a product through a cycle. We call it MVP, or a minimal viable product. So the example we have worked so far, such as the internet-based consumable product, we need to always have a MVP that is being made much quicker so we know how the market is reacting to it. However, with time of growth, how are we going to be able to maintain that any changes in each and every subsection made by a specific machine learning team won't be negatively impacting the successive pipeline? So as a lot of companies have this methodology of maintaining loosely coupled but tightly aligned, and this allow each and every team to bring the best possible innovation in their product. However, being tightly aligned will be able to maintain any changes happen in one subsection would be easily optimized for the successive subsection, and that will allow the business to follow the norm of the way the business been done and maximize the utilization of machine learning algorithm throughout the business process. Thank you so much for patiently hearing throughout the presentation. So in this point of time, I'm going to be able to stop, and let's take any questions the audience have.
That was a presentation by Sayan, Maity, Senior Research Data Scientist at Roku, with his insights on how cutting-edge machine learning techniques can be leveraged to solve core business needs. If you enjoyed this presentation and want more like it, please subscribe to our channel below. Thanks.